So far, we discussed the p-value and confidence intervals. Since it is not easy to decide upon looking to the p-values, we need some standardization of our effects, and that's achieved by giving the effect sizes. The simple definition of effect size is the magnitude or size of an effect. So how much is the difference? Your p-value, your statistical analysis tells us there is a significant difference. But as a clinician, I would like to know how much is this different? Is this effect size big or small? If the effect size is very small, although it is significant, that might not be relevant to my practice. There are different sources of effect sizes, different indices, as we call them. One is the effect sizes between the groups. Then you will hear the odds ratio or the relative risk. Or Cohen has given some values, some arbitrary values for categorizing effect size as small, medium, or large. This is for, of course, the effect sizes for mean differences between two groups. If you have mean differences between two groups, you calculate just easily by taking the mean difference, divide by the standard deviation, by the common standard deviation, and you will have the standard effect size. And if it is less than 0.2, you consider it as small. Then association indices between variables, correlation coefficient R, or R-square coefficient of determination. These are also some other effect size indices, which I will not discuss in detail here. But the odds ratio is very important for us, and you will encounter this frequently. Therefore, let us try to give some examples for the odds ratio. It is very commonly used in case control studies, actually, but also in cross-sectional studies. And it means that an odd outcome will occur with an exposure compared to an odds of the outcome occurring in the absence of the exposure. So the odds of exposure divided by the odds of the non-exposure, we call the odds ratio. The formula is also beyond the objectives of this presentation. Let us see an example for the 95% confidence interval of an odds ratio. Again, taken from a paper, we found that an extended duration of diabetes mellitus odds ratio 1.08, and confidence interval of this odds ratio is 1.01 to 1.16, and the p-value, as you see, is given as significant, 0.022, so less than 0.05. By seeing this, that it is less than 0.005, we should also be able to guess something related with the confidence interval of the odds ratio. As we said, the odds ratio is a ratio between the exposed and non-exposed, the odds of exposed and the odds of non-exposed. So an odds of a ratio of 1 would indicate what? It would indicate there is no difference. My risk is 1 times multiplied by 1 compared to your risk. That means my risk is equal to your risk. But here in this example, it is actually not exactly 1, it is a little bit more than 1, 1.08. And the confidence interval you see is also always, if you do it 100 times, this experiment, in the 95 of the cases, you will have an odds of 1.01 minimum and maximum 1.16. So it will be always above 1, never 0 point something, never less than 1. That indicates that the confidence interval indicates us that this odds ratio is significant. So this p-value is significant. However, although this statistically there is a significance, is it significant clinically? Because this odds ratio is very close to 1.08. So if I tell you that my risk compared to your risk is 1.08 times more, you would probably tell me, hey, this is negligible. Although it is significant, clinically it does not have very much value. So always we look at the clinical significance as well. You see, and we have this non-significance values. For the odds ratio, the non-significance value is 1. If the confidence interval includes 1, that means there is no significance. If the confidence interval is always on the minus side, on the below 1 side, lower side, lower than 1, that means it is significant. If it is always the confidence interval, both sides of the confidence interval are above 1, that is significant as well. But if it includes 1, if it is from 0.9 to something, to 2 to 3, that means it is not significant. Among the treatment effects or effect sizes, we have also the relative risk, and relative risk is experimental event rate divided by control rate. This I have explained in my epidemiological terms slides. And from the relative risk, we can calculate the relative risk reduction. And from that, you should remember that it is possible to calculate the number needed to treat. So here, if the relative risk is 0.46, the relative risk reduction would be 1 minus 0.46, that is 54%. So how would you state this in a sentence when you have to interpret it for your patients in lay language? That would be to say this medication or this whatever intervention you do has a preventive effect. It will decrease the risk relatively by 54%. It is probably better to draw some figures and show them, show this to your patients with the help of some graphs. Otherwise, just showing the numbers won't be enough in many cases. So as I said, this relative risk is used to calculate the number needed to treat, and number needed to treat, the formula, I should remind you again, is 1 divided by absolute risk reduction. If you have a low number needed to treat, that means you by treating less people, you can achieve a great effect. That is, of course, something we want to achieve. If your number needed to treat value is very high, then you may consider not to apply this treatment. This example you should study very well, I think. Here, this is from the German guidelines for treating sore throat. Acute rheumatic fever in Germany is encountered very rarely, 1 in 1 million cases. And 30 to 80% of acute rheumatic fever is expected to cause rheumatic heart disease. So the absolute risk is what is 0.001, the prevalence, multiplied by the risk of having rheumatic heart disease. That is also very low. On the other hand, penicillin treatment, the treatment of group A beta hemolytic streptococci, classically penicillin. If we administer penicillin, we have a decrease of, as given here, 0.0015%. So the absolute risk reduction in this case would be to subtract these two figures from each other, isn't it? To subtract these two figures from each other. And if you do this, you come up with this even still very low percentage. However, we are behind the number needed to treat, so we divide this absolute risk reduction, take the reciprocal of it, and then we come up with a very huge, large number of participants. You have to treat 33,784 people to prevent one rheumatic heart disease. And of course, you in this treatment, applying this treatment, you have to consider that the penicillin, the medication, is not totally harmless. There is also some risk related with the penicillin administration. That's a reason why the German guidelines conclude not to administer antibiotics for sore throat in Germany. So clinically, I assume that is very relevant information. I mentioned about the null value. So just briefly, before concluding this chapter, just briefly repeat it. The no effect for odds ratio, the null effect is 1. So if the confidence interval of the odds ratio is including 1, this is not significant. Whereas if we are talking of the difference between the mean differences, the confidence interval of this mean differences, it should not include null, 0. If it is 0, including 0, that means it is not significant. Okay. Stop here.